Okay, continuing on, now we want to look at antiderivatives. Well, again, certain parts you not know how to take an antiderivative if you have not taken this class at Cal Poly yet, but just do the parts you know. What do you take a derivative of to get a power function? That's easy. Add 1 to the power, divide by that. What do you take a derivative of to get secant tangent? Secant of x. What do you take a derivative of to get 1 over x? Natural log of absolute value of x. And what do you take a derivative of to get e to the x? E to the x. Don't forget the plus c. Again, you're not responsible to simplify any of those. And if I take this problem and rewrite it a bit, that's the integral of 2. That is x to the 1/4, so that's x to the negative 1/4 plus 7 over x squared plus 1. Again, if you have not taken derivative of inverse trig function, you're not going to know what we're doing with this. Here, you would add 1 to the power. Negative 1/4 plus 1 is 3/4. When you divide by that, you're multiplying by 4/3. What do you take a derivative of to get 1 over x squared plus 1? The inverse tangent of x plus c. There it is. And this problem, we know that this is f of 2 minus f of 1, where f of x is, oh boy, okay, forgive me. F of x is, add 1 to the power, divide by that. Add 1 to the power, divide by that. And here you don't pick a plus c because it's a definite integral. So that's simply x cubed plus 2x squared. So f of 2 will be 8 plus 2 times 4, 8. Minus f of 1 will be 1 plus 2. We're looking at 16 minus 3. We're looking at 13. If I make a mistake on the algebra, make sure you're just getting the concept of the problem. Right? I might make an error and you look at the back because I have the answers to those. I gave them to you. Here, we do not know what you take a derivative of this. So what we do, we only know of one technique of integration up till now in first semester calculus. That's all there is. The u sub. And remember how this works. You let u equal the inside of a power function, the denominator of a fraction, the power of an exponential function, the angle of a trig function. So if I let u equal 4e to the x, and I'll take a derivative, that's 4e to the x dx. So I'm looking at this so far. I want to replace this. What would that be? Wouldn't that be simply du over 4? And now we ask the question. The 1/4 is a constant. You could drag that up front. What do you take a derivative of to get sine? Negative the cosine of u. And that will be negative 1/4 the cosine. And what was u? U was 4e to the x. Don't forget the plus c if it's not a definite integral. And there it is. This is what I take a derivative of to get that right there with respect to x. Same deal here. I'm looking at this and figuring out, okay, how am I going to do this? I don't know what do you take a derivative of to get cosine cubed x sine x. I'm going to use the u sub because that's the only trick I know. I'm going to let u equal the inside of a power function. In this case, I know I can write this as the cosine of x cubed sine of x dx. If I let u equal this portion, and that's how I begin the problem. Now I'm looking at u cubed, but I need to get rid of the rest, take a derivative, that's negative the sine of x dx. I'm trying to eliminate, and I see them right there. So what would that equal? Divide by a negative, that's simply negative du, and I could always drag the constant up front if it's multiplied. And wouldn't this be simply add 1 to the power, divide by that? and replace u back. So put a cosine right there. Whether you say the cosine of x to the fourth or the cosine to the fourth of x, you're saying the same thing. For those of you that are not very familiar with trig, there it is. We get to part F. We follow the same trend. The inside of a power function, we let u equal that. So now I have just transformed this problem into u to the 10. Take a derivative. That's the only way to get a dx. That is 12x cubed dx. I'm trying to eliminate x cubed dx, which is right there. So what would that equal? That would equal a du divided by 12, and since I could drag the constant up front, there it is. Now, it would be very wise for you, since this is a definite integral, to switch the limits. Remember, if this is the x, that's x equal to x equal. Since this is the y, since this is the u, I want u equal to u equal. If I take x equals 0 and put it in there, wouldn't that make the bottom limit, the lower limit, in terms of u be simply 7, because you put a 0 there? And if I take x and put 3 for x, 3 to the fourth is 81. 81 times 3 is 243, plus 7, that is 250. Now, hopefully, I didn't mess up the algebra. Let me see. 3 to the fourth is 81 times 3, 24, and 3. Add to that 7, 10. Yep. So now I don't have to go back to x because now everything is in terms of u. And what would that be? That would be 1 over 12 times, add 1 to the power, divide by that, evaluate it from 7 to 250. That would equal 1 over 12 times 12. 12 times 11, 132, isn't it? One over 132 times 250 to the 11th minus 7 to the 11th. And you could leave the answer like that. I see a mistake I made. That's a power of 19, not 10. I wrote 10 right there. And you guys didn't say anything. So here, that's going to change a few things slightly. Add 1 to the power. That's 240. That's going to be a 20 and a 20. There you go. My mistake. I'm sorry. But you get the idea. Add 1 to the power, divide by that, whatever the power is. And when you substitute 250 in, there it is. When you substitute 7 in, there it is. Okay, how about here? The same deal. I see something that I cannot figure out what you take a derivative of just by picking up. You let u equal the inside of the power function. And I know that if you have not taken inverse trig function, you don't know what the derivative of this is yet. But those of you that did, that's 1 over 1 plus x squared dx. So I notice I just put a u and I raise it to the 1/2. And I notice that the x is simply du. And that is u to the 1/2, right? So it's a power function. Add 1 to the power. 1/2 plus 1 is 3/2. Divide by that 2/3 plus c. So that is really 2/3. And the yellow part, substitute that back in, arctangent of x. And there's my answer. I get to this problem and say, okay, well, again, let u equal the inside of the power function. It seems everything's straightforward. Well, the good news, you only know of one technique of an equation. Take a derivative that's negative 2x dx. I'm glancing back and I'm thinking, wait a minute, something's not right. And Why is that? Because it's not working. I have used the wrong color. Oops. I have x dx. So what I have to do, I have to add a middle step. I have to go in there and say, look, that's not matching identically. Before I jump to this, I'm gonna rewrite the original as, and here it is, square root of 1 minus x squared. Do you see that I need an x dx? So I'm letting you equal this still. I'm gonna take one of these x's and put it there. That's gonna match what's boxed. What that leaves me with x squared. So now I could say, look, and here I'm gonna fill everything here so you're not confused. Instead of x dx, I'm gonna have a du, I meant over 2. And that's negative, yeah? But I noticed that I still have an x squared. X squared is right there. If I wanted to solve for x squared, wouldn't you say x squared equal 1 minus u? So this is not as simple. This did come up on few of the homework problems. So now I'm looking at negative 1/2 the integral of 1 minus u times u to the 1/2 du. Well, guess what? That is negative 1/2. Distribute that in. That is negative 1/2. Add 1 to the power. Divide by that. Add 1 to the power. Divide by that. And if you want to distribute that n, that makes it negative 1 over 3. And that makes it a positive. The 2's cancel out. 1/3. And what was u initially? I let u equal, it's right there. 1 minus x squared, and that would be my answer. So, certain problems might require you to do an extra step. That does happen. That happened for us on few of the homework problems. This problem, the same deal. I let u equal. Again, the final is nowhere as long as this. But this review was made by multiple teachers at Pasadena, at Cal Poly Pomona, and they included everything in it, which is why I really like it, and that's why I use it. Put a u in there. Du is simply, dx is simply du over 2. Change the limits on the integral. That will be very wise. If x equal 1, 2 minus 1 is 1. And if x equal 2, 2 times 4 minus 1 is 3. This way I don't have to go back to x. It is a neat trick that you should learn and use. You need that for a second semester calculus. This is 1/2 the integral from 1 to 3 of u to the 1/2 du. And we know how to deal with that by now. Add 1 to the power. Dividing by a fraction is like multiplying by the reciprocal. The 2's cancel out. 1/3. 3 to the 3/2 minus 1 raised to any power is 1. You could write 1 to the 3/2 if you want. That's the same thing. And I get to this problem, and the same deal. Let u equal the inside of a power function. I see a power function. That's the rule of thumb. Du will be 3 the cosine of x dx. So this is the integral. I'm letting u to the 12th power. The cosine of x dx is simply du over 3. And again, I'm left with a sign. I know what sign equal. if I subtract 2 from both sides and divide by 3, I'll get what the sine of x equal. And in this case, I'm looking at 1 over 9 the integral. And if I distribute this in, that's u to the 13 minus 2u to the 12 du. And that would be 1 over 9 u to the 14 divided by 14, add 1 to the power u to the 13 over 13 plus c, and that is 1 over 9 times, remember what u was, and that's my answer. Don't forget the plus c. And u was marked in yellow up there. That was 3 the sine of x plus 2, 3 the sine of x plus 2. And this last example is more theoretical, and let's get that out of the way. If you take a derivative of this, that is simply 100 into 6x plus 2 to the 99 times 6. That's this part. And if you integrate that, well, we know what that is. That is 6x plus 2 to the 100. The only exception, you pick a plus c, because you took a derivative first, and when you integrate, we assume that this is a general function and we add the plus c. Now I'm going to stop this lecture here where we took all the antiderivatives, and then the third video will work with the graphs and all of these type of functions.